Hello students, welcome to Husky Math. Today we will be doing exercises, and before doing it we will see some rules, some important rules. Number one, we have ddx of c equals to 0. Here c represents a constant. That means whenever we differentiate a constant, let us say 5, then the answer will be 0. So here in this section we will be differentiating using the formulas and not by the first principle. Okay, so here ddx of 5 equals to 0 and ddx of any number, let us say 10, so it will be also equals to 0. So this is very important concept you have to remember. Okay, rule number 2, ddx of c times any function of x equals to c times ddx of fx. That means whenever there is a function multiplied by a constant, then that time the answer will be c times ddx of f of x. So basically the constant comes in front of this differentiation. Okay, suppose there is a function 5 times x square. Okay, and if I want to differentiate this function with respect to x, then this times, as you can see, there is a function of x and there is a constant 5 here. Okay, so whenever there is a constant and a function getting multiplied like this, then we can write this as 5 times ddx of x square. So no need to differentiate the constant part. Okay, so this is the second rule. Thirdly, ddx of f of x plus g of x. Here f of x is of any function of x and g of x is also a function of x. That means whenever two functions of x are getting added, then that time we can distribute this differentiation to individual functions like this. Okay, so let me give you a quick example. Suppose there is a function 5x plus log of x. So here two functions are getting added. So if I have to differentiate this sum with respect to x, then it can be written as ddx of 5x plus ddx of log x. So we can distribute like this. So these three rules you need to remember. Okay, next I have listed some formulas, so you can pause the video and copy the formulas in your formula book, or you can take a screenshot and copy it afterwards. Okay, so these are the very important formulas, and we have done proof of all these formulas using the first principle. Okay, so using these 10 formulas we will be starting exercises. Differentiate the function with respect to x. So my function in number 1 is x to the power minus 3. So here we will differentiate this function using this particular formula. So this is in the form of x to the power n, and in place of n I have minus 3. So here n equals to minus 3. So let us differentiate this function. ddx of x to the power minus 3 it will be minus 3 x to the power minus 3 minus 1, because in place of n we have minus 3. So if I simplify it, it will be minus 3 x to the power minus 4. So this is my answer. So you can write like this also, minus 3 by x to the power 4. Number 2, we have a function 1 over cube root of x. So here ddx of 1 over cube root of x. Now the function can be written as 1 over x to the power 1 by 3, since cube root can be written in this way. Okay, so this equals to ddx of x to the power minus 1 over 3. So this is by the law of indices. This is again in the format of this formula, that is ddx of x to the power n. In place of n there is minus 1 by 3. So using that formula we will have minus 1 by 3 x to the power minus 1 over 3 minus 1. So this will be equals to minus 1 by 3 x to the power, if I take the LCM, it will be 3 minus 1 minus 3. So it will be minus 1 over 3 x to the power minus 4 by 3. Okay, so you can keep your answer up to here. Next, number 3, my function is 6x to the power 5 plus 4x cubed minus 3x square plus 2x minus 7. So let us differentiate this function. So the dx of 6x to the power 5 plus 4x cubed minus 3x square plus 2x minus 7. Now here, using the rule 3, we can distribute this differentiation to individual terms. Then it will be ddx of 6x to the power 5 plus ddx of 4x cubed minus ddx of 3x square plus ddx of 2 times x minus ddx of 7. So this will be equals to, so here as you can see, there is a function x to the power 5 and this function is getting multiplied with 6. So I can take the 6 in front of the differentiation. So it will be 6 times ddx of x to the power 5 plus, similarly here 4 is constant, so 4 ddx of x cube minus 3 is constant, so 3 times ddx of x square plus 2 is constant, so 2 ddx of x minus, notice here, then this particular term has a ddx of 7 and 7 is purely a constant. Okay, so as by the rule 1, this portion will be 0 because differentiation of a constant is always 0, so it will be minus 0, and this will be equals to 6 into, now ddx of x to the power 5 is in the form of ddx of x to the power n, and the formula for ddx of x to the power n is nx to the power n minus 1, so it will be 5x to the power 5 minus 1 plus 4 times, similarly ddx of x cubed will be 3x to the power 3 minus 1 minus 3 times of 2x to the power 2 minus 1 plus 2 into, as you know that the ddx of x is simply 1, so I will write 1. Okay, so if I simplify, it will be 6 times 5 is 30 x to the power 4 plus 4 times 3 is 12 x to the power 2 minus 3 times 2 is 6 x to the power 1, which can be written as x plus 2 times 1 is 2. So this is the answer for this question. Next, number 4, I have to differentiate these functions, and I have written formula of the differentiation of trigonometric functions. ddx of minus 5 tan of x plus 4. You can see tan x can be written as sin x over cos x into cos of x minus 3 times cot x can be written as cos x over sin x times sec x can be written as 1 over cos x plus 2 sec x minus 13. As you can see here, cos x and this cos x will get cancelled, and this particular cos x and cos x also get cancelled. So we will have, now let us distribute our ddx also. So it will be ddx of minus 5 tan x plus ddx of 4 sin x minus ddx of 3 by sin x plus ddx of 2 sec x minus ddx of 13. So it will be equals to, now since minus 5 is constant here, so let me write in front, so it will be minus 5 ddx of tan of x plus 4 is constant, so let me write 4 ddx of sin x minus 3 is constant, so let me write 3 in front, ddx of, and here if you have noticed that this 1 over sin x can be written as cosec x, so let me write cosec x here, plus 2 is constant, ddx of sec x minus 0, because 13 is a constant and ddx of any constant is always 0. So now here, as you can see, we will need ddx of tan x, and the formula for ddx of tan x is sec square x. Similarly, ddx of sin x is cos x, and ddx of cosec x is minus cosec x cot x, and ddx of sec x is sec x tan x. So we will be using all this formula here. So it will be minus 5 ddx of tan x is sec square x plus 4 ddx of sin x is cos x minus 3 ddx of cosec x is minus cosec x cot x plus 2 times ddx of sec x is sec x tan x minus 0. That's there. So let me simplify. It will be minus 5 sec square x plus 4 cos x plus 3 cosec x cot x plus 2 sec x tan x. So this is the answer for this question. Next we have root over x plus 1 by x times x minus 1 over root x. So let us differentiate this function. It will be ddx of root over x plus 1 by x times x minus 1 over root over x. So here first we will simplify the function. So it will be, so let us multiply root x and x, then we will have x root x, and after that we will multiply root x and minus 1 over root x. So it will be minus root x over root x. Next we will multiply 1 over x and x, so we will have plus x over x. Lastly we will multiply 1 over x and minus 1 over root x, so it will be minus 1 by x root x. So clearly x and x simplifies to 1, root over x simplifies to 1. So it will be ddx of x root x minus 1 plus 1 minus 1 over x root over x, and here plus 1 minus 1 cancels to 0. So we will have ddx of x root x minus 1 over x root x. This will be equals to ddx of, now see, x root x can be written as x times x to the power 1 by 2 minus, similarly here in denominator also we can write x into x over 1 by 2. So this equals ddx of x to the power 3 by 2 minus 1 by x to the power 3 by 2, because the power of x will get added, as 1 plus 1 over 2 is 3 over 2. So this will be equals to ddx of x to the power 3 by 2 minus, this can be written as x to the power minus 3 by 2. So now let us distribute the differentiation. So it will be ddx x to the power 3 by 2 minus ddx of x to the power minus 3 by 2. So using the formula ddx of x to the power n, we will have 3 by 2 x to the power 3 by 2 minus 1 minus 3 by 2 x to the power minus 3 by 2 minus 1. So it will be equals to 3 by 2 x to the power half plus 3 by 2 x to the power minus 5 over 2. So this is our answer for this question. Next we have 3x squared plus 4x minus 5 over x. This is very simple question. So let us differentiate ddx of 3x squared plus 4x minus 5 over x. This will be equals to ddx of, I can distribute this denominator to all the three terms with the numerator. So it will be 3x squared over x plus 4x over x minus 5 over x. So here it will be this square and this x will get cancelled. So here it will be ddx of 3x plus x and x also get cancelled plus 4 minus 5 and 1 over x can be written as x to the power minus 1. So now let us distribute. It will be ddx of 3x plus ddx of 4 minus ddx of 5x to the power minus 1. So it will be equals to, so 3 is a constant, so I can write 3 in front. So it will be 3 ddx of x plus this portion will be 0 as there is constant only, okay, minus 5 is constant, 5 ddx of x to the power minus 1. It will be equals to 3 times, now since ddx of x is 1, so it will be 1 plus 0 minus 5 ddx of x to the power minus 1 is minus 1 x to the power minus 1 minus 1. So it will be equals to 3 times 1 is 3. Your minus 5 times minus 1 is plus 5 x to the power minus 2. So you can write your answer as 3 plus 5 over x square.